Hi, my name is Zarina Aishamiran and welcome back to my Google Cloud Associate Engineer material. And today's section that I will be discussing is the introduction to computing in Google Cloud. So let's take a look at the agenda for today. The topics that I will be discussing will be VM images, the considerations for running a VM, the types of users, Preemptible Machines, Compute Engine Machines, App Engine, Kubernetes, and then the exam essentials for this section. Okay, so let's start off with virtual machine images. VM images are essentially a template for creating new instances. The images, while they provide the base operating environment for applications that run in Compute Engine. The instances that run the images, they contain the elements such as the operating system, the libraries, and any other code that is vital. There are two ways that you can make an image happen. The first is the public image. Now, you're probably more aware of the public images that are out there because it's most likely that you have used them. So examples of public images would be Red Hat Enterprise Linux, the Linux server, Ubuntu, Windows Server, etc. Then there are custom images. And custom images, as the name suggests, allows you to create your own image. And these could be made from a disk, a snapshot, a cloud storage file, or another image. So to understand this at a more granular level, I have a diagram. And I'm going to go through it. So, an image. What is an image? An image is a bundle of raw bytes used to create a pre-populated hard disk. So for an image to be bootable, it must contain a master boot record, which you can see on the left of my screen, and a bootable partition. For a disk to be imported as a Compute Engine image, the disk bytes must be written to a file named disk.raw. The file is then archived using the tar format and then compressed using the gzip format. You can then upload the resulting file to cloud storage and register it as an image in Compute Engine. After you register that image, you can then use it to create exact replicas of the original disk in any region of Google Cloud. Okay, so let's take a look at the benefits of baking. Now, baking is the process of creating a custom image. So a couple of benefits is the fact that, first of all, there's a shorter time from boot to application readiness. And second of all, there's an enhanced reliability for application deployments. Okay, so now let's take a look at 4 key areas that you would need to consider when running your virtual machine. The first is a no-brainer, cost. It varies between regions, so you want to bear that in mind if you don't really want to have a high bill at the end of the month. The second is data, and whether you're complying with the regulations, whether you put it in Europe, your data, or whether you've put it in Asia, for instance. So always ensure that data is stored locally. The third is HA, so high availability. You want to ensure that if one DC goes down or if one area goes down, your services are still up and running somewhere else. The fourth is latency. Latency is important because it impacts your application, which then impacts whether your users want to use it if it's slow. So these are the 4 areas that you really want to think about when you run your virtual machine. Let's now take a look at how users can be associated with projects. So there are 4 ways that users can be associated with projects. The first is you can have an individual user. You can also have Google Groups. You can have a G Suite domain. And you can also make use of service accounts. So let's look at types of users. So there are 4 types of users when it comes to your project. You can have your compute engine admin, your network admin, so the one that's in charge of VPCs, then your security admin, and your viewer. So your network admin cannot alter instances, by the way. They're just in charge of the network. Your viewer can get and list all of your resources, but cannot read the data from within them. The next topic is preemptible machines. Now, the short description is that they are short-lived machines suitable for running certain types of workloads. So to understand this better, I'm just going to cover the characteristics of the preemptible machines. So first of all, they terminate at any time. And if it terminates within 10 minutes of starting, then you won't be charged. The second is that it's not available across all zones, and you cannot migrate to a regular virtual machine. It cannot be set to automatically restart, and it's not covered by the SLA. It also terminates after 24 hours. Remember, I said they are short-lived machines. However, the great thing about them is that they are 80% cheaper. So now you're probably wondering, okay, they're cheaper, but they terminate at any time, and you can't migrate them to a regular machine, and they're not even available across all of the zones. So why would I want a preemptible VM? Well, like I said, 80% cheaper, so they're highly affordable, and they are short-lived compute instances which are usually suitable for batch jobs and fault-tolerant workloads. So if your applications are fault-tolerant and can withstand possible instance preemptions, then preemptible instances can reduce your compute engine costs significantly. I mean 80% by 80%. So now let's take a look at Compute Engine. If you remember from my previous videos, Compute Engine is essentially an IaaS. So it allows you to create your infrastructure. So briefly, if we look at why you would want to use Compute Engine, well, first of all, you can choose specific images to run on your instances, which you wouldn't be able to do if you don't use Compute Engine. The second is that you get to install your own software, the software that you want, or custom libraries. You also get to control who uses your resources. So let's take a look briefly at Kubernetes. So in a nutshell, what can you do with Kubernetes? Well, first of all, you can create clusters of virtual machines, then deploy container applications to those clusters, and then sit back and administrate the clusters. So you can specify policies such as auto-scaling or monitor the cluster's health. There's a whole bunch of things that you can do, but that is what Kubernetes essentially allows you to do. So let's take a look at the Kubernetes cluster architecture. So you have your master, and your master essentially allows you to manage your cluster services such as your API, the resource controllers, the schedulers, and all of that good stuff on the left. You also are allowed to, well, it allows you to deploy containers into groups called pods. So if you look in the middle of the diagram, you'll see a section where it says nodes, and within the nodes are a set of pods. And within your pods, you have your containers. The containers share the IP and the port space that's available. And then if you look on the right of your screen, you'll see other services that Google provides, which allows you to use those with Kubernetes. So in a nutshell, this is what the cluster architecture looks like. Again, I'm going to be covering this in greater detail in the next set of videos. So, can't wait. Okay, so let's take a look at the exam essentials for this section. So you want to understand how images are used and how virtual machines are organized. You also need to understand preemptible VMs. So what are they and when is the best time to use them? You also need to understand compute engine as well as Kubernetes and how the cluster architecture looks like and how to use Kubernetes, like how does it work? Okay, so that's it for today's video. I hope it was interesting. I hope it was useful. If not, please do let me know in the comments below. And if you have any suggestions, I am all ears. Otherwise, please like, subscribe, and yeah, have a great day. Thank you. Bye.